Today I will discuss logistic regression. First I discuss theoretical part, then I will illustrate this via a practical example. Suppose yi is response, ith response and we have k explanatory variables. Now assume yi follow Bernoulli distribution with parameter pi I. That is, probability yi equal to 1 equal to pi I and probability yi 0 equal to 1 minus pi I. That means each response either take 1 or 0, that is success and failure. Assume expectation epsilon I, that is error part, equal to 0 for all I from 1 to n. This implies expectation yi equal to beta naught beta 1 xi1 beta k xik. So we write it as xi curl prime beta curl xi curl prime denotes 1 xi1 xik and beta curl beta naught beta k prime. Since yi follow Bernoulli pi I, This imply expectation yi equal to pi I. This imply pi I equal to xi prime beta curve. And again, pi I is nothing but a probability yi equal to 1. Note that epsilon I equal to yi minus xi curl prime beta curl. So this is equal to 1 minus xi curl prime beta curl when yi equal to 1 and when yi equal to 0, then this is equal to minus xi curl prime beta curl. We know in linear regression epsilon I follow normal 0 sigma square. So this implies y is not indicator variable. When y is indicator variable, then epsilon I takes two values, either one minus xi curl prime beta curl when yi equal to 1, or minus xi curl prime beta curl when yi equal to 0. Therefore, we cannot assume epsilon I follow normal 0 sigma square. Therefore, epsilon I does not follow normal 0 sigma square. In usual regression model, the errors are homoscedastic. That is, variance of epsilon I equal to sigma square. This implies variance of yi equal to sigma square. But when y is indicator variable, then variance of yi equal to pi I 1 minus pi I. So suppose I denote this pi I 1 minus pi I equal to sigma square. This implies variance of yi depends on yi, and since expectation of yi equal to pi I, so this is a function of pi I, that is mean of yi. So this is not only depend on yi, this is again a function of mean of yi. So first thing here we observe that epsilon does not follow normal 0 sigma square because epsilon takes two value, 1 minus xi prime beta curl or xi curl prime beta curl, depending on the value of y, that is when y equal to yi equal to 1, then epsilon I is 1 minus xi curl prime beta curl, and when y equal to 0, then this value is minus xi curl prime beta curl. So the first thing is, here we cannot assume that epsilon I does not follow normal 0 sigma square. This is first thing. Second thing, we observe that in linear model we assume errors are homoscedastic. So that means variance of epsilon I equal to sigma square. So this implies variance of yi equal to sigma square, but when y is a indicator variable, then variance of yi equal to pi I into 1 minus pi I, which depends on yi, because this depends on the index I. So variance of y1 is pi 1, 1 minus pi 1, variance of y2 equal to pi 2 into 1 minus pi 2. So for this reason, this variance of yi depends on ith observations, and again, since pi I is equal to pi I is nothing but expectation of yi, so variance of yi is a function of expectation of yi. Another interesting thing we observe here, that is expectation yi equal to pi I, and pi I is nothing but a probability yi equal to 1, so this value lies between 0 to 1.